sees your name in lies. Does the sun still scare you? Do I still cross your mind? Oh, I'm feeling hollow, a shadow in the window.
Hey, and welcome back. I'm really proud to see you grow, as we came from limits all the way to here. So we're basically unstoppable. But continuing on, let's look at trigonometry and its derivatives right here. Now, there's a clear formula to follow with all these functions, so I'm afraid it's all memorization. However, a good tip in mind when considering to handle these is how they all start as just regular trig function. Sine and cosine go together here, tangent and secant go together positively, and cotangent and cosecant go together negatively. That's just a good way to think about it. Okay, so now it's time to cover the big rule itself, chain rule. Starting off as a derivative for what composite functions are, you essentially derive what's on the outside first, then soon derive what's on the inside, slowly and slowly until you get to that final function. So let's use this example with f of x is equal to sine squared 12x. So pay attention here because this is way more complicated than you think. Now first, imagine our sine function looking like this. From here, you're easily able to derive what's on the outside, and if we do this correctly, we will get a function of this, 2 to the sine of 12x. Now, it's very similar to power rule here, but here's the next part. Next, we're going to derive what's on the inside of these parentheses, which would be sine. Now, from doing this, we would get a function of 2 cosine 12x times sine 12x. It may look done at this point, but we still have that one more inside function to derive, the 12x itself. So from here, we're going to derive the 12x, and soon we will get our final answer of 24 cosine 12x times sine of 12x. So basically from here, chain rule basically explains that you have to go from each layer to layer. You could honestly imagine it as like a Tootsie Pop rule.